Okay, so our morning sessions on multimodal and agentic AI provides a great segue into our panel discussion. So here we'll now zoom out and explore the broader challenge of building capable and safe AI agents. A key theme that we'll be focusing on in today's panel is this idea of grounding, which is how we connect these agents to the real world, to things like logic and also to actionable tasks. To discuss this, I'm thrilled to be joined by our fantastic panelists. So you've met many of our panelists already through the course of this workshop. So from our speakers today, we have Tao from University of Hong Kong. We have Eric from UC Santa Barbara. We have Sui from Ohio State University, Graham from CMU, and then we have Joyce from Michigan. And then we also have Parisa Kordjamshidi from Michigan State University, who you have not met yet. So Parisa is an associate professor at Michigan State University, where she directs the Heterogeneous Learning and Reasoning Lab. Her research focuses on the crucial intersection of learning and reasoning, specifically in the fields of neurosymbolic AI and multimodal large language models. All right, so we'll get started with the opening statement. So let's have everyone answer these questions. And the question is, what do you think is the single biggest obstacle to making AI agents reliable for real-world use, and how does your research confront it? Why don't we start with you?
Sure. Well, I think it should have become quite clear. Like there's a very obvious answer here, especially for people who have been following the hot debate on Twitter around like the Rich Sutton and the card interview. So the answer here is continual learning from experience, right? We all know that these massive neural networks, they are pretty hard to do continual learning on. You run into all sorts of issues like catastrophic forgetting and undesired ripple effects. Then there are different camps of thoughts here right now, like about like how these LLM-based agents or systems can continually learn. Some people are have very strong belief in RL. I think we can RL all the way to AGI, and some people, which I'm more associated with, believe that RL is not the only solution. It's a very important ingredient. And personally, I think we are heavily investing in like a non-parametric continual learning. So that's where I'm spending a lot of time these days.
So I think actually the nature of the current models is the issue. Like basically you have like these large models that are at the end, they are trained with huge amounts of data, they memorize, and there is kind of pattern matching, if maybe this is debatable, happening at the end. So I think that is inherently is a bottleneck for continual learning, compositional learning, dealing with the new observation that we're not in the data in a way, and dealing them in a way that humans do. So that's why I think to my approach is that I'm thinking, I don't know if that is incremental, but there should be a new school, because we heard from some of the talks yesterday, okay, this older school exploiting graphs, logic, but I think we need that because we want the reliability, we want really to deal with this uncertainty and be explicit about what's happening in the models. So my approach is neurosymbolic. I don't know what will be new school of thought, but at least combining more classical logic, explicit reasoning with these gigantic models that they can do this, exploit the huge amounts of data. Basically, exploiting both data and knowledge is kind of approach that I am following for now. Yeah. Thank you.
Yeah, so there's so many answers to this, but I'll only pick one because I don't want to, preempt the other panelists. But I think the biggest one is that models don't know when they're wrong and don't have the ability to understand when a task is underspecified and ask for more information when it is. So I think better calibrating models so that models and agents so that they ask for help when they need help, and also like don't submit bad work when they have done a bad job. Don't click on the send button on your email when they really should not click on the send button on your email, that sort of stuff.
Yeah, so I think I agree with all of these. There's so many obstacles out there, in fact. So the part that I think, especially related to my work and my group's work on the embodied agents, it's the lack of a word modeling. Okay, so this has been brought up by previous speakers, and also on internet you see a lot of advocate from Yang LeCun and other researchers. And in my own experience, and I am actually really a big fan of that, okay, because I really think that for agents who are gonna live, in our world, they really need to understand this cause effect, right? Their babies from 8 months, they know already how to shake the rattle to induce that kind of action, like hear the sound of a noise. And these agents today, okay, they're trained on a massive amount of data. And for example, powered by large language models, these language models are not, are not word models. And if you listen to ACL 2024 keynote from Rao Kamparti, okay, so he gave a really great argument and a lot of evidence there to show that LLM cannot plan and reason. Especially, I think that in the physical environment, LLMs are not grounded in the environment. And so how do we, you have a second question about how do we do to address that? Because I'm a big fan of that. In fact, back in almost 10 years ago, we started looking something about this type of world modeling, but more from the linguistic side, because I'm a NLP person. So we look at this notion of a physical causality of concrete action verbs, okay? So these verbs, change of the state. And how do we capture that? We did a bunch of studies, on using the web data, using the crowdsourcing data to really identify some 18 dimensions of these physical properties that these verbs can denote changes. And then we also, in 2018 paper, we looked at this paper on what action causes this. We built a small data set to look at, whether the agent has the ability, like if I give you an image of the state, whether the agent can predict, what actions cause that state, and, if I give you action, whether the agent knows what state it can result. But anyway, so to cut it short, I think that we need to have a word model that would allow the agents to plan and reason in a new environment.
Okay, great. So basically, other members mentioned many other great points. Here, I would like to probably add one more specific obstacle for developing these kind of agents. So I think from my point of view, the largest obstacle right now is to how to scale this kind of infrastructure, also environments and the tasks for IL, right? So not just for IL, but also for sandbox testing, right? So before deploying to the real world. So once we have a large number of well-designed environments and the tasks with reliable rewards, we can train the model on this kind of large scale environments and tasks, and also test for example, safety and the security issues before deploying to the real world, something. But for example, here, as far as I know, for example, 2 or 3 years ago, these kind of leading companies like Anthropic or OpenAI, they spend large amount of money on collecting this kind of instruction following data. But nowadays, just as I mentioned in my talk, they have been investing 1 million, almost 1 million this year on building this kind of large-scale pool of environments and tasks for general IL training to train their next generation, these kind of agentic foundation models. But here, scaling this kind of environments and tasks is not just about a number, right? So it's about how you design these kind of environments. So for example, how you're going to define this kind of observation space and the action space out there, and also tool set available for this kind of agent training. So for example, the action space, how you define, right? So GUI, for example, do you want to have like a pure GUI action space, or have like a coding or like a MCP action space out there? And in this kind of environment, do you want to provide some very specific tools? For example, like some APIs found for some specific functionalities, or you want to provide some basic essential like MCP or APIs or some setups for like an agent to play with within the environment, right? So, and also, do you want to have like environments for specific for coding, for example, Bash environments, and like a web browser for web agents, or like a general, the whole like a virtual machines for like a generalist computer user agent training, this kind of stuff. So I think it's also related to, very similar to like embodied like AI, just like what happened there, just like how to scale these kind of environments and to define these kind of tasks with like reliable reliable rewards. Yeah. So.
All right, great. Thank you for the for all the your kind of also discussion about your own research and how that ties in. So we're going to move on to some core questions for the panel. I just want to note that we will have a chance for audience questions in the last 15 minutes. So we're going to start with some open-ended questions now. I welcome strong disagreements among panelists. So feel free to go as hard as you would like. So the first question that we have is actually a great segue from Tao's comments. So many of you have worked on different aspects of grounding, and grounding itself is a kind of a very versatile term. So some of you have worked on things like grounding to syntax, grounding to semantics, code generation, robotics, computer agents, these kind of things. The question is, how do these different approaches to grounding, and obviously we have many kind of grounding specific models that we've seen even over the course of today. How do these different approaches fit together? Are they complementary? Are there some sort of synergy that you've seen over the last few years? Or are there some sort of inherent tension in these approaches? Feel free to jump in immediately after someone else if you have a remark.
All right. Okay, maybe let's start with something concrete. Like on computer use agents, grounding was a big challenge. Like back in 2023, 2024, when we first did a work called the C Act, we literally put the title as a paper as like GPT-4V is a generalist web agent if grounded, because grounding in this like VLMs back then were very, very bad. But then in just like less than a year, if you look at the current frontier agents, they're very good at grounding, right? Like if you try like Cloud 4.5 computer use or GPT-5 computer use, they're very good. I tested so many cases and rarely run into grounding issues anymore. But this is just like this like element level grounding. But if you think about like grounding in a more broadly, then it's also about like processes. For example, I can say eventually to me like grounding is a representation and translation problem. Like different environments, different people have like different representations about the same thing, and how do you translate between them? And then for like let's say for the same task of, well, the boring task of booking flights, like different users may say it differently, and it's represented in weirdly different ways on different websites. Then so the grounding is eventually such a translation problem. That I don't think we have sufficiently tackled yet. I'll just stop here.
So I also think like grounding in general, I mean, if you think about it, like you ground language into knowledge graphs, you ground language into code, you ground language in vision. So to me, it's like perhaps more than a translation is connecting two different worlds. And then I think when we connect two worlds, usually the second world might give me another media for evaluation, for what we call understanding. So I mean, if I do reason over symbols in natural language, I might do meaningful things inside the scope of the language. But how, when I connect that to the visual world, then there are a new medium, new constraints, new kind of semantics that are created in the new modality. And I can evaluate actually the type of reasoning in the first modality. Or if I connect to action, then I can really relate the first modality to the physics of the real world. Maybe at the language level, that is not possible. Or if I connect to the code, I will have a medium to now check different aspects of syntax or semantics from a different perspective. So I think connecting from one world to another gives me possibility for what we call another meaning, another medium of evaluation, and bringing in different dimensions that don't exist in the first modality. So that's why I think always this grounding is giving us kind of advantage. If we are thinking about understanding is more philosophical, but I think it's one aspect of understanding is grounding one modality to another. Yeah, just.
Or I can just also chime in a little bit on top of what Parisa said. I think that I really agree with that notion. Is for me, okay, the grounding is such a loaded terms, but then some kind of a general behavior is, I feel like, okay, there are very connect to what you said, is 3 components. The first component is about the agent representation, agent generation, whatever the output of capabilities. And the second component is about this external world. The world that beyond the agent itself, okay, it can be the external world of code, it can be the physical world, it can be the physics of the world, like the perception, action, and also the world has other things, like the rules, right? The rules of the social rules that we conform to, and the moral standards, or these are all the external things beyond this agent in the world that govern how the world works. Again, back to the word model again. So then this grounding is the translation is like connecting this internal agent representation or behavior with this external, physical, whatever the world, and we can use this world to not only verify, but also use this world, whatever captured in this world, to drive the behavior of the agents, to meet that kind of standard. So, so that is the part I just want to add a little bit to that notion. And also, I think that grounding, also there is not just the world, there is the communication grounding that is also the grounding is like my representation and your representation, right? So how do we employ different mechanisms so that we're on the same page? Because at the end of the day, these agents are going to work with humans, right? So this is another line I think is very important.
Let me inject some controversy into this. I think these are all really great points. I think one of the things that I've noticed in science, we try to really isolate for specific phenomena, and then we test methods and algorithms for those. So for instance, I say, I'm going to investigate generating SQL, something I've done. But so then what I would do is I would look at a database in isolation, right? So when I do that, though, I'm going to kind of split off all the other things that are happening in the world, like social dynamics, what's implied by language, and these kind of things. And it almost sounds like what you've been advocating for is perhaps we need to fundamentally rethink how we design experiments and craft hypotheses to actually get away from this tendency to isolate for very precise phenomena and instead allow other things to come in so that we can explore these kind of codependencies and interactions between them. So how do you kind of see, if we were to try to pursue this idea of transfer between modalities and different grounding mediums, how should we rethink the way we conduct our experiments and formulate our hypothesis? A question for Joyce. we can. Oh, sure.
I mean, as I mentioned, it's like it's connecting two worlds and depends on our purpose, right? If I want to just visualize what is expressed in language, I connect it to the visual modality. But if I want to see what is the social implication, maybe I have to connect it to the social rules. Or if I want to do some sort of other type of reasoning to infer things, maybe I have to ground it to some abstract concepts to be able to logically reason over that, right? So then I think it depends on our purpose and our affordance, how we really want to analyze this piece of information and which kind of modality is going to give me that like content or information for the analysis that I want to do. So yeah, that's, I think I hope I answered a bit.
How do you, Graham, do you want to chime in here?
Okay. Yeah, yeah, I just wanted to add some points on top of that. Just like my short answer is like definitely like a grounding into different representations will be much more like complementary as these kind of foundation models capability keep increasing. So basically, a very like interesting finding here, basically from this kind of workshop, right? So nowadays, even for the like research community, people working on like agentic research nowadays, most of them are from like a semantic parsing or code generation background, right? For example, early days like Luke and Yuval Azi, and also Graham working on like code generation, and Fred stuff like generating Python code, and also Victor, Su Yu, and I, and also many others like Siva also working on this kind of tech to SQL stuff, right? So 10 years ago, we basically used different models for different purposes and studied them separately, and have different benchmark, different environments, different models, different evaluation pipeline stuff. And but nowadays, all these kind of things come together, right? Because of like foundation models, and also this kind of research community, we also saw this kind of convergence, right? So different people working on different directions come together and working on this kind of stuff. And also, as I mentioned in my talk, I also believe like people working on robotics and also digital AI agents, they're gonna come together, like not just like robotics people, or reinforcement learning people, or like CV people, or NLP people, agentic people. They're gonna come together, also working on the similar problem, solving this kind of general problem. Even though they basically this kind of system requires to ground like language or perception into different kinds of like modalities and also representations stuff. So yeah. So yeah, this is basically my take.
Cool. So my fundamental approach to grounding is I'd like to get as close to the source as possible when I'm grounding things. And so if we think about speech has an underlying sequence of words, and that underlying sequence of words is symbolic. And then on top of that, we're essentially, adding noise, prosody, all these other things. Maybe they add a little bit of information, but usually don't change the underlying semantics. And so it would be kind of silly to generate speech and then try to do speech recognition to try to solve the problem of language understanding, I guess. And I kind of view like working through GUIs or browsing on web pages is a similar thing, right? We have an underlying representation of what that web page originally was, and that's symbolic. And then we're generating images and trying to act over the images. And so I know I've done a lot of work on web browsing, and we created a benchmark called Web Arena that a lot of people use and stuff. But recently my thinking has been, with MCP becoming very popular and lots of APIs being available for agents, now we can ground directly to the source. Directly to the database, directly to the file that lives on your file system and other stuff like that. So I'm generally kind of moving in that direction. note this doesn't mean that like vision language understanding is not important. There are a lot of places where it is important because in the physical world, the source is, maybe it's not an image, maybe it's atoms, but at least the closest we can get to atoms is taking an image. So there we'll need vision language understanding. Also humans, we observe the world through vision typically, or our other senses. And so when we present information to human, we'll need to present it in a visual way or in other ways like this. But I think MCP, I disagree with some of the design decisions that went into MCP, but the fact that it's standardized and gave agents lots of tools that they can use to interact with the source of the data is really, really powerful. So I think that has done more for grounding than most other things. And so if you wanted controversy, there's,
Great, thank you, Greg.
there's my controversial take about it.
Who wants to take on that controversy? Let's go.
Actually, this was really my first. Sorry, maybe you want to say something first.
No, you can say.
I had really this question because I don't work on these web agents, and it was really last 2 days I was trying to understand why people work on this visual interface of web pages, why that is a problem, and as you mentioned, why we don't communicate with the actual information. So, I mean, now you're saying, okay, there is this standard that coming up, so now it makes more clear to me that I thought this is really a fake problem in this middle. I mean, why we should deal with the vision and language problems in the web agent perspective, because we need the reality vision and language problem. If I'm talking about interaction, natural interaction with the web systems or digital world, then I'm just directly working on the natural interaction, why I should work with the interface that is built for the machines, right? So I need a machine-machine interaction or human-machine interaction. What is my goal here? So yeah, but thank you clarifying.
One quick clarification about this. I don't think it's a fake problem because there are some websites that you can't interact through APIs and stuff. And also, I think Tao's presentation was really good at thinking about like computer use agents as one step towards agents that operate in the physical world. So I think they're still useful from that point of view. But we don't need to invent fake problems and make things harder than they are. So I agree with that.
I just chime in a little bit. I think there are different types of agents. Okay, so in my talk, I mentioned like there is the digital world. Agents with the digital world with some digital actions, the physical agents in the physical world, like robots, the physical world and the physical actions. And then there are some other potential agents in between that could exist in the physical world, like those smart glasses, and then taking the digital actions, right? So depending on the scope of these agents, the world is a little bit different. But then still, I think this connection with what is in that world, digital world, there's a software world, there is the digital data, databases, facts and all that. These type of a physical world, there's what we see, what we touch, what we can operate on. And then there's the rules, like in the digital world, and there's the rules in the physical world. And all of these, actually, they're coming together. It's just a different type of a content that we're trying to model.
Right. I love this. Graham knows my real position on this problem. I'm more like middle of the road. I'm not like I don't think like GUIs is the ultimate way. I also I'm a big fan of MCPs and the coding and everything. But just for the fun of the debates, I think maybe Tao and I can be more on the GUI side of things. GUIs are amazing. There are a couple points. One, GUI is largely information complete, except some corner cases that Graham and I discussed before. It is the de facto interface most people are using to interact with the digital world. So whatever you want to do, chances are it's already doable in GUI, as opposed to like in API or anything like that, to that effect. So it's much more, the current coverage is much, much better than APIs. Then one can say, okay, with the popularity of MCPs and everything, maybe we will quickly transition over GUI to like an API-driven world. But then creating a high-quality API and maintaining a high-quality API is incredibly hard. We may have like some bias as developers ourselves to underestimate the difficulty of that, but for most people out there, it's very, very hard, right? And for most of the things that are not at the head of the distribution, it's very hard. I am very positive that the APIs will play a increasingly important role, and but I also think like GUIs are here to stay. There are more reasons, but maybe I can say more if we get to that. But I'll just stop here for now.
Okay, probably I can add also a little bit more spice here. So the reason I also support this kind of GUI-based approach, vision-based approach to doing this kind of computer user agent, this kind of stuff, I think if we look ahead one more step, if we want to have a single, just as I mentioned in my talk, have a single foundation model working in both like digital and physical environments, you can, if they just observe this kind of visual context, for example, like screenshots for digital agents, and also this kind of just like real image of the real world, right? For the robotic control, this kind of stuff as the input. Then in this case, we can have more unified input and output space for training this kind of foundation agentic model that can work in both like a digital and the physical environment. So in that case, you won't have, for example, very specific like sensor data for robotics training and very specific like API or MCP calls for like a digital agent training, right? For example, if you design this kind of MCP, very specific MCP or APIs, what kind of like APIs, what kind of list of like APIs and MCP you're going to provide to the agentic agent training? This is a very, very big problem. If you provide too many, probably the agent you trained on top of this is very specific, are gonna be very, very specific and cannot generalize to other scenarios. But for example, if you just train on these kind of virtual inputs, so you can basically it's much more has a much higher like possibility to generalize to different domains and scenarios in that case. So this is basically my argument.
Why this screenshot helps here, the screenshot input-output thing. Can you clarify on that?
Yeah, so my argument here is like if we use screenshot for training this kind of digital AI agent, if we adapt this kind of approach, then we can better have more common like findings and also methodologies shared with other domains. For example, training also have this kind of foundation model that can operate in the physical environment, because for the robotic agentic foundation model, basically they see all the see the image of the real world, right? So if you train like a digital AI agent on this kind of HTML or accessibility trees or APIs, then you don't have this kind of stuff in the real world for robotic training, right? So this is.
Well, maybe I have a counter argument there. Maybe there isn't a model that you can train for the screenshot and work well in the physical world. Maybe that would confuse the model if you have these image of the screenshot. And I know the methodology-wise you want to use the similar kind of a methodology to do it. But then for the practicality-wise, I wonder, whether it's just a question, right? So the physical world is very, in terms of the information, is very different from the screenshot. So that's just a question. I mean, also on this, at the same time, I think we should embrace the diversity of approaches.
Yeah. Speaking of generalization, I saw an interesting example recently where we asked Claude to use GIMP which I think is one of the things from OS World. And it does really well if you put it in the Claude sandbox, and it's like, okay, now I need to select the fill button, and that's the second button on the second row. And so it clicks on the fill button, it finishes the task. We came up with a slightly different sandbox that had a slightly different dimensionality, and Claude looked at the screen and it's like, oh, I'm using GIMP. I should click the second button on the second row. But because we resized the window, it was actually the third button on the second row. And so it clicked on the second button on the second row, and it's like, this is not working. I wonder why this is not working. And so if we're talking about generalization, I would say that visual models have probably bigger generalization issues than models based on text. But you know, I'm not entirely anti GUI interaction, but I did see this interesting example recently.
Yeah. Basically, to clarify, I also support like both like different approaches. But just I want to add more like a perspective here. Just like yeah. So basically, if you use like pure version visual like inputs for this kind of, for example, digital agents, definitely gonna have some like issue about like efficiency and also other reliability stuff. But yes, there's another. If you can consider more about like one single foundation model for all kinds of like scenarios, environments, or something. Probably virtual inputs like approach is much general and complete.
I think this is a nice segue. I think we had 3 questions in the plan, but I think maybe we can jump to the third one directly, which is this idea of how the capabilities of these agents will affect the safety of our everyday systems. Right now, you know, there's this thought that says, you know, we should scale this, and we've kind of scaled out the data that we can find on the internet. So now we're scaling in the amount of simulations that we're doing, for instance. And there's the casual remark by, you know, some leader at a tech company that says we should be doing essentially reinforcement learning in real life on, let's say, the economy, right? So I think this also has implications. The discussion that we just had about essentially what's the right level of abstractions for agents, whether this is GUI or whether this is some sort of programmatic interface, I think also has some downstream impact for what the world looks like for humans, right? So if we design our computer systems primarily for agents, then, you know, in some sense it removes agency from the human users. So I'm curious to hear your thoughts on, as researchers, what should we be thinking about? And, you know, also maybe for folks like Graham and you, if you're actually deploying these systems into critical infrastructure, what's the trade-off, or how do you consider the trade-off between capabilities and safety?
I have a mic, so I could go first. You'll notice I mentioned the biggest challenge that I said at the very beginning was knowing when to stop. And I think that basically stems from this because, you know, I use agents all the time, and sometimes they start doing things that I don't want them to do, and I have to ask them to stop. We've also had examples where, you know, like it will do things like deleting important files. We saw an example of the replit like agent deleting a production database and stuff like that online. So this is definitely very, very real. I would argue that we may or may not need different interfaces for humans and machines, but we definitely will need more robust permissioning systems for what agents are allowed to do. And a really good example of this, which is still not perfect, is GitHub. So GitHub has very, very fine-grained permissions about what you allow an API key to do, for instance. And so it's like you can edit the workspace, you can edit the you can edit the workflows, you can edit the code, you can edit the issues and stuff like that. This doesn't exist for humans, actually. There's no fine-grained permissioning system like this for humans. It's only for API keys. And the reason why is because people are more concerned about the security of automation than they are concerned about the security of like a human with good judgment doing these things. And so I think that's probably how we're going to have to approach this. So number one, permissioning, which we have in some APIs, but not other APIs. Number two, much more research on knowing when to abstain from doing things, knowing when to stop. How do we train models to do that? How do we evaluate models doing that?
Right. I think there are actually two parts in this question. There's the safety and security aspects, and there's the agency, human agency aspect. For safety and security, first of all, it has become a real problem. It's not just like a research problem anymore. Like, for example, people have played with like Perplexity Comets or like Claude for Chrome, and you can literally do like real indirect prompt injection. You send an email to this person with some bad intent, and then if this person has its email connected to like one of these agents, then it can read this email, follow the bad intent instructions there, and send like your secrets to another place. This is already happening, so it's a real problem. Then to solve this, I think all of the things that like we discussed in this panel are relevant. Like I talked about continual learning from experience, right? That's because no one can know everything a priori. You have to learn on the job. Then it's also about word modeling. Like what you are continually learning is also a kind of word modeling that okay, if I do this in this context, what would happen? And because of the consequences, I should not do that. And it's also related to permission and things like that. So there's that. I think this is a great workshop that featured a lot of like the latest developments in the safety and the security space on agents. I highly encourage everyone to pay more attention to this. And then for the human agency part, I'm actually not that worried about that. I think we'll see better collaboration between human agents and AI agents. There are a lot of the things that I don't, as a human user, I don't want to own the agency. Like, let's say for these deep research systems, there are so many tedious low-level things that I have to manually do and manually decide. I want to transfer this agency to these AI agents so I can spend my limited cognitive capacity on things that matter more, like these critical decisions, oversight, and things like that.
Okay, so I actually really appreciate this workshop, okay, because I have, been really coming from the embodied agent side, like robots, simulated robots in the physical world, but we know that is still far, okay? It's not here yet. But then, this workshop brought these digital agents. In fact, I feel like a lot of these safety issues, reliability issues that, digital agents working on, you work on this, will eventually, be, the embodied agents will have to address these issues as well. So it's really provide this tremendous knowledge towards the building the embodied agents. But then I can only say a few words about the embodied agents because that's my research area, is there are a lot more, certainly for robots to work with us, right? To make these robots reliable, fundamentally, I think is the grounding. Okay, I really appreciate that the theme that Victor put is the grounding, right? So the grounding is that this world we are humans are so familiar with, so good at, and these embodied agents, they are not, right? So how to ground to this, what we see, what we can do, what we feel, and then we already talked about other type of grounding. So I think that to really improve the reliability, we really have to start from grounding, okay? Make these things grounding to the world and learn from such a grounding. In fact, a lot of work has happening in that space, right? I've shown that the trained models, like from the grounded data, that can help, learning better, planning better, reason better, and that type of thing. So.
Oh, okay. Yeah, so here.
Sorry, let me just jump in. We're going to start the audience questions soon, so please step up to the mic if you have a question ready, so then we don't have to wait for people to walk. Sorry, Tao, go ahead.
Okay. Yeah. So just as like Chai's mentioned, I think, for example, this kind of grounding this kind of language and act like a perception into some like explicit like representations actually help us like develop these kind of agents, safe agent, and also debug this kind of stuff, because all these kind of actions this kind of agent are going to take are basically represented as explicit in this kind of grounded like actions sequences, right? No matter it's like a code, SQL code, or like action sequences, control robot arms, or like GUI actions. So basically, you can if you find some errors and the failures, you can trace back to their like grounded action sequences there to debug there, right? And also related to like what Charles mentioned, like in embodied AI, there are some like also some like simulated environments out there, right? So and also many people are also working on this kind of we call like actually if we consider this kind of simulated like a world model as like related to this kind of simulated environments are kind of like symbolic world model, right? So basically here, if we have like a very good simulated environments or very good like world models for physical and digital interactions, then we can train the model and also debug this kind of safety and like privacy issues on these kind of world models via these kind of world models, and also in like very good like simulated environments together before deploying to the real world, right? So yeah.
Can I maybe rephrase or maybe add a little bit? So I mean, if we assume that following up on the Joyce comments, if we assume that the next frontier for improving intelligence, I'm not talking about the like safety, but for improving intelligence, we need the real world interaction and embodied AI, and that is what we want to do. Then I think in general, if you allow the models to do whatever and explore the environment, I think, okay, that the models become more creative and more intelligent. As humans is the same. If you constrain people, they will have limited intelligence, rather than you allow exploring everything, making mistakes, and interact with the real world, then you get more intelligence. But then here, since we are more caring about security and safety from the AI agents, then it seems that I think we need to allow this interaction, and then the safety measures can come into play when I really need to ground to really understand the implications of that action. And then maybe have like constraints. Okay, if you see a wall, you have to stop. You cannot hit the wall. You don't need to hit to see the consequences. I have this piece of knowledge already. So basically, we can really inject this explicit knowledge and reasoning into the models, even in the course of interaction, and providing distant supervision through the interaction. So that is, I think, the way that we can maybe control allow the models to get supervision and also control them to what to do, what not, for the safety and security.
Great, thank you for the great response. I think actually maybe an interesting idea is if you can have some sort of permission system for the physical world that says things like, you know, you're allowed to do things, but if it's not reversible, then no, you can't do it. These kind of things. Great. Okay, let's start with some audience questions now. I see some heavy hitters lining up for the mic, so please go ahead, and we'll try to take maybe 10 to 15 minutes of audience questions. Please go ahead.
Awesome, fantastic. Can everyone hear me? Amazing. Okay, I have a quick question for you all. So one thing I feel like hasn't been discussed too much, but is a core component, is uncertainty that the agent has. So specifically, when I think about agents, so I'm a roboticist, right? But when I think about agents, I'm looking at it through that lens. And when I think about things like text or images, these are just simply like lossy projections of the true state of the world. So for example, like a web agent that's going to shop on my behalf, the text prompt it gets and the images it sees are just a partial observation of the true things that matter for that task. For example, the amount of money in my bank account, right? Or my risk tolerance for how, let's say, you trade on my behalf. Or maybe my credit limit. And at deployment time, it's unclear if the agent has access to all of the relevant information it needs to make proper decisions. And so what happens then? How do we get a handle on this kind of uncertainty when you're doing large-scale deployment, how should we model it, and what should the agent do? And I'm curious if any of you have seen this in your own work, and what's that frontier look like?
Yeah, so I talked a little bit yesterday about one of our papers where we basically took the very well-specified issues on SweetBench and turned them into underspecified issues and tried to get language models to ask questions from a fictional user that had all the necessary information. We're actually training models to make the models do better at this, and there's actually some other concurrent work trying to do similar things. For us, any evaluation environment you can create can also be turned into a reinforcement learning environment as long as you make, enough data from it. And so that's essentially the approach that we're taking. I think we need a lot more evaluation environments that can be turned into reinforcement learning environments, and I think that will make a lot of progress there, at least for the types of problems that I'm interested in working on, but I'm interested in what other people think too.
Yeah, the calibration and uncertainty estimation are very, very challenging for the current models. On the other hand, I just provided one perspective from memory. That's what I pay a lot of attention to lately. A lot of this has something to do with the missing context, right? It's impossible to ask a user to specify every detail in the request that will defeat the purpose of the agent, be it like AI agent, like digital agent or embodied agents. But on the other hand, because we are using these systems so much, like I'm personally a very heavy ChatGPT user. It knows so much about me, and ChatGPT has come up with at least 3 different kind of memory systems, capturing different level information at different granularities. So these days, I think it has gotten so much better at filling in the missing context for many of the things I do with it. It is a scary future that these AI systems know so much about us, but yeah, it does help with this problem quite a bit. Not yet, but I think so. The recent added this shopping feature, and yeah, I'm thinking to add that.
Got it. Thank you.
So I wanted also to comment a little bit on the uncertainty from my work perspective. So actually, I agree that perception always is uncertain, but hopefully we can have explicit reasoning more clear, and then reasoning can kind of give feedback to the perception. So that is the idea that I am following. And back to the main issues that also Graham mentioned, the model when the model doesn't know. If the model can recognize things at the perception level with the high confidence, then I'm going to rely on it, right? But if I have a way to really measure the uncertainty of the model at this level, then I can decompose and do the exact reasoning, or not exact reasoning, at least reasoning, explicit reasoning, considering the explicit uncertainty measures, then I can do kind of more reliable decisions. So that is, I hope that I can do that, but I think the bottleneck here is how we measure uncertainty of the models, how we calibrate the, basically the probabilities that they generate, or the inconsistency to be measured of uncertainty. So these are all research challenges, how to measure the uncertainty. But then, yeah, if we can do that at the lower level, then we can do reasoning, explicit the reasoning at the higher level. That might be more reliable technique here.
Yoav, did you want to?
Yeah, so I'm kind of curious about, so Victor tried to push on that at some point a bit earlier about security of this system. So Bowley gave a talk, I think it was yesterday, and I think the general message was we are creating this giant attack service that is extremely complex and operates, the minute you connect your agents on your computer to an external environment like the internet, you create an adversarial scenario. And I hear a lot about capabilities, about how everything is capable and stuff like that, and that's great, and I'm very impressed. But once you deploy this stuff at large scale for a lot of users, you create this huge attraction for scammers, hackers, all the good people in the world, to basically take advantage of people. And I don't know if I don't know. And that's part of the question. I don't know if there is if this is even evaluated, and if we have a good understanding of it. So I think Graham was talking about we are going to ask for permissions all the time. So that reminds me of these 5 levels of autonomy, of autonomous cars, and that failed miserably, because once you go autopilot for 1 hour, you don't really expect the person to wake up 10 seconds before they hit someone, right? So is there any kind of thinking about this? Are there any benchmarks, evaluations? Do we have any good understanding of what will happen when our brittle agents go into the adversarial world?
There's so many benchmarks.
There are benchmarks.
We had a paper, Open Agent Safety, and in our paper, we tried to do a survey of all of the previous benchmarks, and there's a table of 15 to 20 different benchmarks on agent safety. One thing you will note is that this is never released in, or maybe it's not never released. It's never released in the blog post for a new model that came out. It might be released in the agent capability section of the technical reports. But I think yeah, it's I think more attention needs to be paid to it. Admittedly, I've been developing agents for a while, and we're just getting around to appropriately benchmarking safety. We've been doing a lot of qualitative worrying about safety. And making sure that we have things in a Docker sandbox so they don't delete all the files on our computer and stuff like that. But in terms of benchmarking, we haven't done as much, and we probably should be doing more. I think there are a number of mitigation strategies that people can use. And number one is using an aligned language model like Claude or GPT-5 that has a pretty good idea of what it should be doing and what it shouldn't be doing, although it's not perfect. You can also do post hoc editing, and we've had post hoc editing. There's a bunch of startups that are basically building post hoc editing auditing tools that you can drop in and use to stop your coding agent before it does bad things. I don't know about or coding or web agent. I don't know about embodied stuff as much though.
Yoav, I'm curious. Are you more asking about if you had a system that's at scale, how are people going to adversarially interact with it, or are you more wondering about?
So you have kind of a number of, the interaction is basically between there is the model, there is the person, right, that's using it. That's hopefully not an adversarial person, because that's not what I'm concerned about. I'm not trying to build my software so it's hackable by a third party. But then these agents are going around and grabbing information from elsewhere. So for example, going to Graham's point about coding agents, I can imagine injecting some information online about a library that someone's using by creating some documentation. OpenHands or any other agent goes online and looks for help, finds it, and injects into my code a backdoor for the hacker to use. I think it will be very hard for me as a developer that relies on longer and longer code generation to catch. And this kind of stuff, it's like spam, right? But it's a much more powerful, operating in a much more powerful paradigm. And largely, we have failed to deal with spam. People are being hacked and cheated out of money all day, every time. So now we are creating a higher stake environment that we don't really know. I don't know if there is, and I understand that there are benchmarks. I just don't know how I trust these kind of benchmarks. But I'm not an expert in that space, so I'm curious to hear what everybody is thinking about the state of evaluation in that scenario.
Yeah, first of all, I think for these digital agents, their attack surface is very scarily broad. I totally on board with that. And now we are spending way more efforts in developing the capabilities than the safety and security aspects, which is also scary. I think people are catching up. I think you mentioned Bo's work, which is great, and also Juan talked about her work on environmental injection attacks. On we also created benchmarks called Red Team COA that allows you to benchmark these kind of things. And then generally, there are two categories of safety risks. What I call endogenous risks. So it's from the agent within, like usually due to the agent not being competent enough, so it will unintentionally do harm and things like that. And recently we released a data set exactly for that called the Web Guard. That so we annotated like thousands of these actions at different risk levels on the web. And we also test like this frontier LLMs, and it turns out to see how accurately they can predict the risk level. It turns out they are all pretty bad. Especially they tend to classify these like highly consequential actions, like with legal implications, with like financial transactions as safe ones. So that's pretty worrying. But we also fine-tuned a small model that's much better than that. But it's still far away from the 99.9% we need for these kind of things. So I think the community is realizing the importance of this. We are catching up, but there's still a long way to go.
Okay, cool.
I don't know. I actually don't have much to say about these the security attack and all that. But I just want to add one thing is that because I'm still coming from the embodied side, right? So in fact, at the end of the day, the embodied agents is a software agent, within. So all of these, like yesterday, we see the Juan's talk, and right now the from Yu, all of the security issues that would eventually applicable to the, because if the robots are built on these kind of powered by these agents, right? But then the robots also have some other security and safety issues that these type of agents do not address, right? Especially because the robot working with humans in our human space. There are so many things about human side, naturalistic kind of a behavior, the natural phenomena in the physical world that robots need to be aware, right? So there are a lot of efforts. We're starting to see effort in the embodied side to look at the safety issues. For example, recently there's at the Coral, there's this one paper from, I think it's from maybe DeepMind, okay, looking at, it's called ASMO benchmark. So ASMO, we know about the laws, right? Robotics laws, don't hurt people, and what is the next? Orderly, be orderly, follow the order, and be, keep your existence, protect your existence as long as the previous two conditions met, so on. So they built this benchmark. The benchmark has like images of the different, like a scenario, a scene, right? So for example, there's a little kid next to the recycle bin, and then there is the robot, okay, to the recycle bin. And what the robot gonna do, right? So they also generate lots of different instructions and trying to build train the model to see that, okay, in this condition, how do you take care of, like, you have to really worry about the kid's safety, right? So you cannot just directly go put your can to that to recycle bin. You might have to take a longer route and so on. So basically build a large benchmark, okay? The benchmark would allow to learn these type of safety issues and also, for the technology development. But is this enough? Of course, this is just the beginning. Thank you.
Yes, so, okay.
Okay, maybe let's have a last remark from Tao, and then we'll break for lunch.
Oh, okay.
No
Yeah.
pressure.
So basically, I think this there's no like a perfect solution right now here for measuring like either like capabilities or safety of these kind of agents. But I think one thing definitely we can do is like how we can scale this kind of evaluation like procedure before deploying to the real like human worlds, something like this. So there are two things: how to scale this. First is how do we scale like different testing scenarios, tasks, right? So basically we can scale humans like a crowdsourced platform to scale like to let like a large number of like real users with real needs to test this kind of embodied AI agents, either like digital AI agent or physical AI agents, right? So actually, we have seen some like recent work. For example, in like robotics domain, we have seen some like people build this kind of robot arena, right? So basically, they provide this kind of few amount of like a real like environments, and you deploy to you submit your like robot policies to them, and they set up to the to their connect this kind of policy to like a real like their real like robots and perform this kind of in this kind of real environments, and the people can ask any kind of questions and observe what kind of like consequences, and if this kind of robots finish this kind of task as well. So basically they collected probably so far I think like thousands of like robotic evaluation data points from there, which is much larger than the prior research in the robotics like community. And also for the digital agents, we have seen a lot like arena platform out there. But there's another key bottleneck here is like how we can scale. How can we scale this kind of environments or sandbox for large scale like testing, right? So for the physical environment, it's very hard to have like millions of like real world environments for testing, right? But for digital environments also, there are a lot like anti-bots, like a protection measure, for example, rate limits or IP issues out there to scale like a very big like number of like task environments for testing and like capabilities or safety, potential safety risks out there for some like robots. So basically, this is also one potential solution is like just like research in like water modeling, and also probably we need to build much better or scalable like simulated environments for measuring this kind of like a capability or safety behind this kind of AI agents stuff. Yeah.
All right, thank you, everyone. I'm sorry I have to cut this short. I do realize I'm stopping you from lunch. So in the this is a great segue, because in the afternoon we'll actually have Andrea and Zhizing talk about safety specifically, and refusal and recovery, these kind of behaviors. So please join us in the afternoon. We'll see you at 2 p.m. And then please join me in giving our panelists a round of applause.